Hi everybody, welcome back. So today we're going to be looking at multi-step equations with squares and cubes. So today, instead of simplifying using square roots and radicals, we're actually going to be solving. So remember what solving means. We want to find out what value, or values in this case, and we'll talk about that in a minute, we can plug in for our variable that's going to make our equation true. It's going to satisfy the equation. So one thing I want to talk about really quickly is when solving equations that have squares and cubes, there is a possibility that there's more than one answer. For example, if I were to take, and I'm going to use parentheses here to help show what I mean. If I were to take 3 squared, remember what this means. 3 squared means 3 times 3, which is 9. Okay? But what if I take negative 3 squared in parentheses? What does that mean? Do you guys remember this from the beginning of the year? So negative 3 squared, when the negative 3 is in parentheses, means I'm multiplying negative 3 times negative 3. And negative times a negative gives me a positive 9. So do you notice how 3 squared and parentheses negative 3 squared both produce 9 as an answer? So if I were to take the square root of 9, now before when we were simplifying, we said 3, right? So the square root of 9 is 3, because 3 times 3 is 9. But now we actually know that there's 2 answers here. There's 3 and negative 3. And the way we write that is we put this little plus minus in front of the 3. So when we're solving, we want to make sure that we're including every possible answer when we take a square root. And in this case, the square root of 9 was plus or minus 3. We could take a positive 3 squared and get 9, and we could take a negative 3 and square it and get 9. That's the same type of thing if we were looking at 4 squared. 4 squared is 16. Well, how about negative 4 squared, if I put it in parentheses? What does that give me? 16 as well. So if I were to take the square root of 16, there's 2 possible answers here. I could get a positive 4 or a negative 4. Because if I square a positive 4, I get 16. And if I square a negative 4 in parentheses, I also get 16. So today, when we're solving and we take the square root of values, we're actually going to come up with 2 answers for those problems. So let's go ahead and dive in, and I'll kind of show you as we go why both answers work here. So when we solve equations, there's a couple things we have to remember. So the first thing, we're going to follow the normal steps for solving multi-step equations. So we're going to use the distributive property to get rid of any parentheses if they're there. We're going to combine like terms. We're going to move variables to one side of the equation. We're going to undo any addition or subtraction through inverse properties. We're going to undo any multiplication or division through inverse properties. And then we're finally going to take the square root or cube root. So we want to get that variable squared or variable cubed all alone before we square root or cube root, before we undo that squaring and cubing. So let me show you what I mean by all of that with question 1. So question 1 is 3x squared minus 5 equals 70. So our goal here is to figure out what value or values of x would make this equation true. What could I plug in for x that would make this equation work? So if this was earlier in the year, I would start by adding 5 to both sides. And then dividing by 3. So I'm getting my variable, and in this case, my variable squared, all alone. So this gives me x squared equals 75 divided by 3 is 25. Now, I added 5 to both sides because I wanted to use the inverse of subtraction. So I wanted to undo the subtraction by adding 5 to both sides. And because it's an equality property, whatever I do to one side, I have to do to the other. I divided by 3 to undo the multiplication between the 3 and the x squared. But whatever I do to one side, I have to do to the other. Now, to get just x, so x squared is great, but I want to know just x. What is just the variable x? So to undo a squared term, remember we square root. And whatever I do to one side, I have to make sure I do to the other because this is an equality property. So my square root undoes my squared, leaving me with just x. Sorry, I'm going to bring this up top here. And the square root of 25 is positive 5, but it's also negative 5. Because remember, positive 5 squared gives me 25, and negative 5 in parentheses squared gives me 25. Now, just to show you how both 5 and negative 5 work, I'm not going to do this for every problem. I just want you to see why we have two answers for this particular problem. So if I were to plug in, so remember when we did checks? Again, we're not going to make you guys do that now. I just want to show you. I'm going to do my check in red here. So let's say I check to make sure that positive 5 really does work as our value for x. So wherever I see an x, I'm going to plug in 5. I'm going to put in parentheses. Following order of operations, I'm going to take care of my exponent first. So 5 squared is 25. And then multiplying 3 times 25, I get 75. And 75 minus 5 is 70. So notice how my right and my left side match. So 5 is definitely one of our answers. It's one of our values for x. But now, let's make sure negative 5 works too. So negative 5 squared is 25. And now, if you look, I'm right back in that step here. And I know, if I were to keep going, I know this is going to work. So negative 5 and positive 5 are both answers to this particular question. Now again, I'm not going to show you a check each time. I just wanted to show you how, when you take the square root of a number, you actually come up with two answers, not just one. All right, let's take a look at number 2. So number 2, solving for n. Again, I want to find out what n values work in this equation. I'm going to start using inverse operations. And first, I'm going to undo this subtraction here by adding 100 to both sides. So that leaves me with 288 equals 2n squared. To undo the multiplication between 2 and n squared, I'm going to divide by 2. And when I divide, I have 144 equal to n squared. And to undo a squared term, I'm going to square root. And remember, anything I do to one side, I have to do to the other as well. So these guys cancel each other out, leaving me with just n. The square root of 144 is one of our perfect squares. It is 12. But remember, our answer is going to be a positive and a negative 12. Because positive 12 squared is 144, and negative 12 in parentheses squared is 144. All right, so let's keep going. Looking at number 3. So we have these parentheses, and we want to get rid of them so we can get m all by itself. So I'm going to start by distributing the 2 inside the parentheses. So 2 times 3m squared gives me 6m squared. Plus 2 times 2 is 4. Okay. All right. I'm going to undo this addition with subtraction. That leaves me with 6m squared equal to 216. I'm going to undo this multiplication between 6 and m squared with division. That gives me m squared equal to 36. And to undo this squared term, I square root. 36 is a perfect square. The square root of 36 is positive and negative 6. So I can plug in positive 6 or negative 6 for m, and we would have a true equation, or an equation that works. All right, continuing on, looking at number 4. Okay, so number 4, the first thing I'm going to do is I'm going to divide both sides by -5 because I want to undo that multiplication between -5 and x squared. So dividing here, I get x squared equal to, remember, a negative divided by a negative gives me a positive 100. Undoing a squared term, I square root, and that leaves me with x equals 100 is a perfect square. It's 10, but don't forget, we're going to make it plus or minus. It could be a positive or a negative 10. Both of those are going to work in my equation. All right, continuing on to number 5. Seeing the parentheses first, I am going to, I'm going to distribute. So I get 3x squared minus 4 times 3 is 12 plus the 2x squared equals 13. So you'll notice on the left side of the equal sign, I have a 3x squared and a 2x squared. These are like terms, so we can combine them. Because they're on the same side of the equal sign, we can just go ahead and add the two together. So this gives me 5x squared. Remember, the x squareds we don't combine. We only combine the coefficients, which are 3 and 2. This minus 12 we don't do anything with just yet. Okay, so keep working on getting x squared all alone. I'm going to add 12 to both sides so I can undo that subtraction with addition. And I'm left with 5x squared equals 25. I'm going to undo this multiplication with division. I'm going to move off to the side here. And I get x squared equals 5. So this isn't going to come out super nice, but at the top in our directions, it says round each answer to the nearest tenth if necessary. So I have a feeling we're going to have to do that here. So let's undo this squared term by square rooting. Now the square root of 5, so again, if you go to your calculator and you hit second x squared to pull up the square root function, take the square root of 5, close the parentheses, and you're going to get a pretty long decimal here. So it's 2.236067978, and we're going to round that to the nearest tenth. So x is approximately, and remember, we still have two answers. They're not the prettiest, but they're two answers nonetheless. So rounding this to the nearest tenth, we get x is approximately plus or minus 2.2. Okay. All right, looking at number 6. Looking at the left side of the equal sign, there's definitely some things that I can combine here because they're like terms. To start, this 6x squared and 3x squared are like terms, and if I combine them, that gives me, ooh, that is a crazy 9. Okay, 9x squared. We have -2 and positive 9. Those are like terms that we can combine, and that would give us a positive 7. And then equals 70. Okay. So undoing the addition with subtraction on both sides, I subtract 7. Undoing the multiplication with division, I divide by 9. I get x squared equals 7. So once again, this one isn't going to come out whole, but that's okay. To undo a squared term, I square root. So I get x is approximately, because we're rounding here, so I'm going to go to my calculator. I'm going to say plus or minus. So when I go to my calculator, again, second x squared key to pull up the square root function. 7, close the parentheses. I get 2.64575131. Rounding that to the nearest tenth, I get 2.6. Okay. So that one you won't be able to check because we had to do some rounding. It won't turn out nicely. But with any numbers that do end up whole, you are welcome to check these, or I should say as integers, because they could be positive and negative. You are welcome to check them. Okay, so moving on to number 7. Let's see, I do have like terms. They are on opposite sides of the equal sign, so I have to get everything that's like on the same side. To start, I'm going to bring this 4y squared to the other side, and I'm going to do that through subtraction. So that leaves me with 6 plus 5 minus 4 is just a 1. Y squared. Now you don't have to have the 1 there. You could just say y squared. I'm going to subtract 6 from both sides because right now 6 is positive and we're adding it to y squared. So I'm going to subtract 6 from both sides. And I get 16. To undo the squared term, square root. And we get y equals 16 is a perfect square. So I say plus or minus 4. All right, on to number 8. Okay, so this is a cube here, so an x cubed. So let's work first to get that x cube all by itself. Eventually, we are going to be cube rooting to get just x. So to start, I'm going to undo this subtraction with addition, and I'm going to add 50 to both sides. So 1/2 x cubed equals 500. Okay, so remember what's happening here. This is 1/2 times x cubed. Now dividing here, so if we were to divide by a half, think about what we know. Dividing by a fraction is the same as multiplying by its reciprocal. So we're going to keep, change, flip here. So instead of dividing by a fraction, we're going to multiply by the reciprocal. And whatever we do to one side, we have to do to the other. Now these guys cancel, leaving me with just x cubed on the left. 500 times 2 is 1,000. Okay. Now to undo a cube term, we cube root. So remember that's the little 3 outside the square root symbol. And whatever we do to one side, sorry, I still can't write all that well on my tablet, so bear with me. So whatever we do to one side, we do have to do to both. The cube root undoes the cube term, leaving me with just x on the left. To take the cube root of 1,000, so on your calculator, you're going to type a 3 first, then you're going to hit second, and you're going to hit that little kind of caret, that little like up arrow that's in between the pi key and the x squared key on the left side. So you'll see it says x and then the square root symbol. So this is us telling the calculator we're taking the cube root, and now we put 1,000 underneath that square root sign, and we get 10, because 10 times 10 times 10 is 1,000. Now with cube root, no plus or minus. Because if we were to cube, so think about it this way, 10 cubed, which is 10 times 10 times 10, gives us 1,000, right? 10 times 10 times 10 gives us 1,000. If I take negative 10 cubed, that's negative 10 times negative 10 times negative 10. Well, negative 10 times negative 10 is positive 100. And then positive 100 times negative 10 gives us negative 1,000. And that's not what we wanted. We wanted to get positive 1,000 here. So when we're cube rooting, we do not have two answers. We only have one. So in this case, x equals just 10. It does not equal negative 10 as well. All right, looking at number 9. Another cube root, so we've got to be really careful. So let's see. We've got some things we can combine. They are on opposite sides of the equal sign. That's okay. This 4a cubed and 2a cubed, those are like terms. I'm going to bring the 2a cubed to the other side through subtraction. And I have 2a cubed plus 12 equals 28. Again, the goal right now is to get a cubed all by itself, so I'm moving everything away from it using inverse operations. So this plus 12, I'm going to subtract from both sides. Now I'm going to undo this multiplication with division by dividing by 2 on each side. So now I have a cubed equals 8. And now when I cube root both sides, I'm left with a equals 2. Okay. Now you can always check your answers. You don't have to, but you're welcome to. And there are ways to do it. I know it takes a little bit, but if you're really concerned about what you came up with, you are welcome to plug this value back in for a and see if it works in your original equation. All right, number 10. So let's see. I'm going to start with distributing that 7, and I get 7y cubed minus 28y plus 20y minus 10 plus 8y. Ooh, we're running into my little example over here. There we go. Equals 11. All right, so combining a bunch of things. Oop, not just yet. 7y cubed. We're not combining that with anything. However, negative 28y, positive 20y, and 8y are all like terms because they have a y. Now, negative 28 and a positive 20, if I combine those, leaves me with negative 8y. But then I have this positive 8y over here, so my y terms all cancel out. So I don't have a y term at all. All right, but this negative 10 or this minus 10 here, I do still have to bring down and work with. All right, so I'm going to add 10 to both sides. And that gives me 7y cubed equal to 21. I'm going to divide by 7 to undo the multiplication. And I get y cubed equals 3. Now 3 is not a perfect cube, so this is going to come out as a decimal, and that's okay. So let's cube root both sides. And when we do that, again, we're going to round to the nearest tenth here. We get y is approximately 1.4. Okay, and again, we only have one answer here, positive 1.4. Okay, so let's apply this to some circles. All right, so the area of a circle is 53.38 meters squared. What is the radius of the circle to the nearest 10? We're going to use 3.14 for pi instead of that pi key on our calculator. So, going back, okay, oh goodness, we have to really remember here, what is the area of a circle? What's the formula? Okay, so the area of a circle is pi r squared. So if we think about all the things that we have here, we were told what the area actually is. It's 53.38 meters squared. We were told to use 3.14 for pi. So what we're missing and what we need to look for is r. Okay, so we're going to solve for r here. So taking this equation, a equals pi r squared, I'm going to plug in everything I have. 53.38 for a, pi is 3.14, and then r squared, r again I don't have. I'm going to solve for it. All right, so let's undo this multiplication between pi and r squared by dividing by 3.14. Now when I do that, I end up with 17 equal to r squared. All right, so I just want radius. I don't want radius squared. So to undo this squared term, I'm going to square root both sides. Okay, now I can already see 17 is not a perfect square, so it's going to come out as a decimal. I'm going to make sure I round to the nearest tenth. So I get r equal to, and don't mind me kind of writing backwards here, plus or minus I should say r is approximately, huh? 4.1. Now, let's think about this for a second. Now, in the equations on the previous page, it was okay for us to have positive and negative values as our answer for our variables. Now, in this case, does it make sense for us to have a positive radius and a negative radius? Think about what we are looking for here. The radius of a circle is a measurement. How can our measurement be negative? Does that make sense? Is there a circle that can have a negative radius? No, that doesn't make sense. So in all of these problems here, when it comes to us applying what we're doing and when we're solving for specific variables, in this case, because the variables are representing some type of measurement, it doesn't really make sense to have a negative answer. So our answer, our radius, is approximately positive 4.1 meters. Okay? We're only going to use the positive values now, just like we do when we simplify. We only use the positive values. All right, looking at the area of a circle again, the area of a circle is 376.8 feet squared. What is the diameter of the circle to the nearest foot? Okay, diameter, don't forget, is 2 times the radius. So we have to keep that in mind. Now, reminding ourselves again, the area of a circle is pi r squared. We know A. They gave that to us. We know pi, we're going to use 3.14. R, we don't know. We don't know the radius. So we have to first find the radius, and then once we have the radius, then we can go ahead and find the diameter. So let's do that. So plugging in all the pieces that we have into our formula, we have 376.8 equals 3.14 times r squared. All right, so undoing that multiplication with division, I get 120 is equal to r squared. Now, I know 120 is not a perfect square, so let's work with this here. We're still going to take the square root on both sides, and I'm going to show you what I get on my calculator when I take the square root of 120. So when I take the square root, I get, and I'm just going to flip these around here, I get r equals, and I'm not going to bother writing the negative value here, because again, remember, we're talking measurement. So 10.95445115. So you see how it's a really long decimal. We are going to be rounding our final answer to the nearest foot. We typically want to wait to round, though, until we're done with the problem. And right now we're not done because we found the radius, but we have to find the diameter to actually finish the problem. So right now what I'm going to do is I'm going to leave r as the square root of 120. I'm going to leave it as that because really that is what this decimal represents, the square root of 120. So now I'm going to use that to find the diameter. So the diameter is 2 times r. Now r, I said, is the square root of 120. So going to our calculator, I'm going to type in 2 times second x squared to get square root 120 equals, and I get another long decimal, 21.9089023. Okay, I'm going to round that to the nearest foot. So 21.9 is going to round to approximately 22 feet. So the diameter is approximately 22 feet. Again, I apologize for my writing on here. I swear it is so hard sometimes. Okay, number 13. If the area of a circle is 219.8 meters squared, what is the circumference to the nearest meter? Man, we are just making you access all sorts of prior knowledge right now. Okay, so circumference of a circle, just in case you don't remember. 2 pi Okay. All right, so once again, we need to find R. So that's really the only thing that we don't have. So area, pi r squared, we know A is 219.8. We know pi is going to be represented by 3.14. We don't know R, and we need R in order to find the circumference of the circle. So let's find R. Okay, so plugging in to our area formula first, I'm going to take 219.8 equals, we're going to use 3.14 for pi. So you can see these problems are all starting out the same. We're going to get r squared by itself by dividing both sides by 3.14. Now when I do that, I get 70 equal to, r squared. 70 is not a perfect square, so when I take the square root of both sides, I am left with 8.366600265. You know what? I'm going to say this. I'm going to say r equals the square root of 70 for now. And the reason for that is I'm being asked what the circumference is to the nearest meter. So I don't want to start rounding just yet. Let's wait until we're finding the circumference and then we'll do some rounding. So for now we're saying r is the square root of 70 and we're leaving it as that. Okay, let's use this r value now to find the circumference. So the circumference is 2 times pi, which we said use 3.14, times r, which is the square root of 70. Now we can go ahead and type this into our calculator. We can even use the parentheses if we would like. So 2 times parentheses 3.14, close the parentheses, parentheses, square root of 70, and then close those parentheses. Now I am getting, and I'll show you the long decimal and then we'll round, 52.5422496.7. Now we're going to round to the nearest whole meter. So 52.5, we're going to round to 53 meters. Okay, so there's our circumference of our circle. All right, continuing on. The volume of a cube. Okay, think about a cube. All sides are the same length. Length times width times height, all the same length. So the volume of a cube is 74.088 centimeters cubed. What is the length of one side? So we just said the volume of a cube is side times side times side, which gives us side cubed because all the sides are the same length. Okay, we know the volume. We were told it. 74.088 centimeters cubed. Okay, so I'm going to plug that in for my V, my volume. And I'm going to solve for S. So remember, to undo a cubed term, I'm going to cube root. Okay, so when I cube root 74.088, and remember to cube root on your calculators, hit 3, then second, and that little caret key that's in between the pi key and the x squared key, and then 74.088. So this gives me a value of 4.2. Okay, so what is the length of one side? It's 4.2 centimeters. And you can check your answer. You can take 4.2 cubed, again, put that in parentheses, cubed, and see if you come up with 74.088. Okay, last but not least, the volume of a cube is 125 meters cubed. Okay, similar to the information we were given before. First thing we're going to do is find the length of one side. So exactly what we just did in the previous problem, volume is s cubed. Okay, so I know the volume is 125. I'm going to take the cube root of both sides And I come up with, let's see, cube root of 125 is 5. So S equals 5, or in this case 5 meters. Now we're going to find the area of one face. So if you think about it, a face, the face of a cube is a square, okay? So we're going to find the area of basically a square. So the area of a square is side squared, okay? So we know that the side lengths measure 5. So plugging in 5 for S, we get an area of 25 meters squared. So that's just for one face. Now, how many faces are there in a cube? Well, if you were to draw it, and now my cube is not going to look spectacular, so bear with me here. I am not an artist. I think I connected wrong things here. I did. I drew it out of order. And some of my artists in my classroom. Okay, so here's my not so wonderful cube. So how many faces are there? So we've got 1, 2, 3, 4 on the bottom, and then 5 and 6. So there are 6 faces in a cube. Here we go. And if each face has an area of 25 meters squared, to find our surface area, we're going to take 6 times 25. All right, so 6 times 25 gives us a surface area of 150 meters squared. All right, and that concludes the lesson for today. Hopefully you guys were able to stick with me. If you have any questions, don't hesitate to let us know.